Hey, hello everyone. This is week five lab session. During this lab, we're going to be going through the project for this week. I want to begin by exposing you to this document. There are two very important documents right here. AdventureWorks Data Dictionary. I'm going to get to that, and AdventureWorks Relationship Diagram. Right. I think we know you can actually build this one yourself. Right. So let me go back to Management Studio. If you access any database and you want to explore how the relationship for that database can be built, you can always go to database in question and you just simply go to database diagram right here. And once you right click on this, you may have an option to install something. Just go ahead and click on that and install. Or you can just go direct to new database diagram. The system will first of all start by showing you all the tables that are available in the database you're trying to build a diagram for. So if I just select everything, see, I just put my cursor somewhere right here, click hold and drag across. Another way is to click one, add, and this is kind of a little bit lazy. Click the next, add, you're adding them one at a time. I don't like this option. So it's just better to highlight everything. Or sometimes you might just isolate two tables and you want to see if they are related. That's another way. So let's start by highlighting everything. Just click on add. So we are adding all of these tables into the database diagram. And the system is going to put in place the diagram for us. Right. So this is what we call database relationship diagram. It basically shows you all the tables that are available in the database and how they are related. So once everything has been populated, just close this. And this is the diagram right here. See that? All right, this is very, very important. And that's the database diagram for AdventureWorks. This is the biggest database we have in the training. This is provided by Microsoft. So this AdventureWorks, this one right here, this is a database diagram that somebody has built in a PDF document, and they've colored it based on the schemas. Right. So the color you see on the tables ties to the schema. Right. So if you go to the AdventureWorks database, expand, go to tables, you will see the different tables and the databases and the schema, sorry. So for example, the department table is in the human resources schema. The address table is in the person schema. So all of this right here, all these tables, you can find them in this document and how they linked up to one another. See that? So this is very important. Also, you can isolate maybe two tables and just want to see how they are related to each other. Let me take an example in an equation we're going to build today. If I go to week 5 project, so instead of building everything, you can just isolate two tables you're working on a project, 2 or 3, and you want to see how those tables are related to one another. That's also very possible. Just permit me to open, yes, right here. Uh, you see what happened? I don't like using this option where you just double click on a SQL file to open. It opens another instance of SQL Server. You see, this is the one I was using, and then I just double click on the file, it opens this one. So it's always better to stay on the copy you have and just launch a new file from the copy you have. So I'm going to stay right here and just go right here, this, and then I open the file I'm targeting. That's week 5 lab, and this is the file, week 5 lab project open. You see, it preserves the same copy of Management Studio and opens the file in the same copy. This is the diagram I was talking about, and this is it, you see. So in this first example, we're going to be using this database, this AdventureWorks database. Right. And in this database, we're going to be using these two tables right here. It looks like I opened the wrong one. Did I send you all of this with the... Okay. Which one did I send out? the one with the solution or the one with just the question? Let me check out the next one. Just a moment. This is the one you're supposed to receive. So it looks like I did a mix up on that, but that's still fine. I'll just, yes, this is the one you're supposed to receive. Okay, right. Okay, I'm just going to stick to this one. So if you look at question one, they want us to use this table and this table for question one. See, so definitely we're going to join these two tables if needed, right? You can just go to Management Studio and investigate the relationship between these two tables. We have the person table in the person schema and the employee table in human resources, right? So instead of going to this huge database diagram and I struggle to identify those two tables, I can just make a copy. I can build one for myself and just focus on those two tables. Because based on this question, we need the two tables, you see. So you can just go to the database, right click on database diagram. If you have this, you can click on this or this, it's still going to get to the same area. But click on this, click on yes, and now it's going to proceed. So from here, I don't want to load all the tables. This is going to take a long time to build a database diagram, right? I just want to isolate the two tables I need in that question. I need the person table. And I need the human resource, oh, just a moment. Let me go back and check the two tables I need. So I need person in the person schema, employee in the human resource. Right, let's go back to the schema, the database diagram. So when you identify the table, just click on it, hold down the control key, and then look, find the other one and click on it. So first, let me look at person in the person table, person on the person schema. Okay, I need this one right here. Employee table, human resource. So I'm going to just hold down the control key, and then I'm going to keep scrolling down to look for the next one, which is a person in the person table, this one. Now I'm going to add this two only to the database diagram. I'm going to close this, and now the system shows me that yes, these two tables are related. You can always drag and centralize them, these things. Yeah. See that? And I can explore the relationship. I can right click and go to properties and go to this right here. See, under tables and column specification, there's three dots on the far right hand side. And I can just see that these two tables are related based on business entity ID, business entity ID. See that? This would have also been easy if you just stay on that project and do a select star for these two tables. Right, that's the first one. So if I want to start solving this, first I'm connected to Adventure Works 2022. Then the second thing I'm going to do is run a select star from the two tables I was told to use in this question. That's the first one. And then the second one is the person one. See, the question starts by telling you use this and these tables for question one. And I'm going to copy this and just put it right here. An easy way to also look at the mutual column was just to execute both queries and see which column is common to both. We have business entity ID right here and business entity ID right here. And if you go to the database diagram that we printed, you're going to see that the two tables are linked together based on that. So once you have this, it's not really clear what is the mutual column. You can just right click on the relationship line, go to properties, on tables and column specification. Once you click on it, you go to the far right hand corner, you're going to see the three dots. Click on that, and this is a relationship right here. So the person table and the employee table are related through business entity ID. Right, so that's the column you're going to use to build a join. Right, and now you can start by putting those information together. Let's build a join that involves those two tables. That is going to be the first part of this question. Right. So I'm going to call this E for employee. I will do an inner join, and I'm going to bring this table, the person table, right here, and I'm going to call this P. Yeah, I want you to understand that the first question is, what is the name of the CEO? If you go to the employees table, it's just going to show you employee informations without names. So names are not stored in the employee table. The names are stored on the person table. You see that? So we need this so that we're going to observe the job title, and from there we should be able to identify the CEO, that's the Chief Executive Officer. So we need this table. Now we need the name, the first and the last name. So we need the person table to find that information. So you see the names are stored on the person table. The employee table does not contain names. See that? So if you want to if you want to project information that can be traced to two different tables, first you have to connect the two tables together. So you can do that through that investigation right here, or you can just execute the two queries and then find out the mutual column right here. But to be very confident and sure about this process, I'll always recommend the database diagram. This tells you how the business considers the two tables to be joined together. This is what the business recommends. If you want to join the person table and the employee table, you have to make use of the business entity ID. Right. So if you go now to the on clause, I can then call employee.business entity ID. So from the employee table, you're taking business entity ID equal to this. You understand why we are putting the E and the P reference, because this column is ambiguous. If I just remove this reference, remove this and just put business entity ID, we're going to have ambiguity error. See? So I need to tell the system that this version right here, let's find it from the employee table. And this version right here, let's get it from the person table. This is a revision. See? Now, this is how you create a join between those two tables. Right. And now we are ready to answer the first question, which is to investigate, to find in the name of the CEO. Right. What column carries the names? It's based on the person table, and it's simply stated as first name, last name. You can ignore the middle name for now. Right. Now, let's get to work on this. So first name, last name, right here. And they told us to do what? Concatenate first and last name into a full name column. So we have to combine these two columns into a single column, and the name of that new column will be full name. Right now, they are separated. And that's when we recall of a function, which is the concat. The concat function is built from this process called concatenate, which means to combine things, right? So if you want to combine first and last name into one column, you simply put the concat function and let the system understand that these two will be concatenated. So it takes an expression, comma, takes another expression. You can indicate a long list of expressions to join them together. And make sure you comma separate them. So if you look at the next attempt at this query, the two columns, first and last name, are now into one column. See that? And we see that major issue of experience with the plus sign when you join using the plus sign. So we've made a lot of progress. We are moving away from this idea of using the plus sign to join things. And we are now using a function called the concat function. But in the concat function, no plus sign is needed. You have to replace that with a comma, and then you indicate the function concat in a set of parentheses like so. And of course, this gets the job done, but then we need a space between the first and the last name. They are all fused together. And the same knowledge, same idea to put a space is maintained right here. See that? So we have first name, comma, this expression which brings in a space, comma, and this. So this is the full syntax of the concat function. The things you want to concatenate together and just comma separate them. I want to take the first name, concatenate it to a space, and take the last name and concatenate to that space so that there should be a space between first and last name. And this is what we get, you see. And the question tells us to call this column full name. Right, so we're going to use an AS keyword right here as full name. Right, and with the space in between, I need to put my square brackets right here. Right. If you look at this question, we've been able to show the first and the last name of all the employees combined. You see, we have a total of 290 employees. See that? 290 employees. But this question was very specific. They want to get the name of the CEO, the Chief Executive Officer. Right. And when we combine these two tables, we saw, if I just go back to asterisk, just give me a moment, go back to asterisk and pull this. There was a job title column right here. And you see first on the list, Chief Executive Officer. Right. So if you want to get that first and last name of the Chief Executive Officer, you have to introduce a condition which will go fetch that information. And that is contained in the job title. So this is going to be where job title, right? Job title. Remember, this job title column is coming from this table. Why the first and the last names are coming from the person table. That's why we had to join these two. If you put this as given in the question, then you're going to get an empty set because the names of the job title is not abbreviated. It's actually in the Chief Executive Officer. But the question talked about CEO. So if you just copy the CEO and you just put it on this condition, see what happens. You get nothing. You see that? Right. So you have to go back to the, how the system stores that title. It's Chief Executive Officer. That's the CEO. So I have to copy that in full and put it right here. So this will now limit this number of rows to only the person that has job title Chief Executive Officer. I once had this in an interview. We're discussing the difference between the where clause and the having clause. At what level is the where clause implemented in a table? The condition on the where clause is implemented at the level of the row. This is very, very important, you see. So this condition will specify right here, and the system will take this condition and go to the first row and investigate, is job title equal Chief Executive Officer on this row? The answer is yes. It's going to keep this row. See that? It goes to the second row. Is job title equal Chief Executive Officer? The answer is no. This is how you implement a condition on the where clause. For each row, if there are 50 million rows, this will be tested on each of the rows. This is very important, right? Meanwhile, the having clause will impose a condition at the group level. See, in this case, we are targeting the individual rows and we are testing the condition on them. Row 1 is job title equal Chief Executive Officer. Yes, this is it right here. Row 2 is job title equal Chief Executive Officer. False. So this condition will be implemented across all the 290 rows and the system will only show the one that is true. See that? This is very important. If you want to also add job title as a column on the list, you can just do that and put the job title right here so that we see the first and the last name joined together and the job title clearly is right there, Chief Executive Officer. So only one person is the CEO of the company and that's that person right there. That was the goal of this question, and the function to review is the concat function. So you have to go back to the lecture material and check. So we have moved away from the plus sign to combine things. We are using the official function which is tasked to do this is the concat function. So that's the goal of this question right here. And so when you combine the first and last name, and since we are focusing only on the CEO, we have to add that condition job title equal to that. This is it. Let me share this with you all, and I will be ready to answer questions on this particular project. Any question on that? I think that was straightforward. This right here is B. We're just going to add the start date. So when did this person start working for AdventureWorks? So AdventureWorks is a company, and these are the list of employees, and the names are stored in this table. So what we see right here is just the name and the job title, prove that it's the CEO. We're going to add another column to indicate when the individual started working for AdventureWorks. So this is going to be a scenario where we're just going to copy the same stuff, right? And then we're just going to add the column that indicates the start date. And if you go back to the table to explore this information, you can, so that will likely come from this table right here. The employee, just go right here, just run this. Right, there is a hire date right here. Hire date is the date the individual joined the company. And now this will lead me to the second PDF. Let me explain the second PDF. So on the first PDF, we talked about the database diagram. Second PDF is the data dictionary. Let me open this. I'll go ahead and open that data dictionary. It's simply a document which shows you every table in the database and the columns, and then it gives you a description of what that column is capturing. This is very, very powerful document. Right. So for example, we are looking at the employee table. So you're going to go, I want to find out information about the columns I see on the employee table. I have to first of all go to the PDF document. The first column is what the schema. So I have to know that the employee table is in the human resources schema. So I go to the PDF document, it's right here, human resources. The table I'm investigating is not department. I'm going to skip until I see employee. I will start on this. This is the portion for information about the columns from the employee table. You see that right here. And every single column you see on that table is documented on that PDF document. It starts with what? Business entity ID. So if you're exploring this table and you don't know the meaning of business entity ID, what that column is all about, you can just go to the PDF document. Once you've identified the correct schema and you're on the correct table, this is the column right here, business entity ID. And you see under definition, it tells you primary key for employee records. What does this mean? It means that no two employees should have the same business entity ID. That's the concept of a primary key. You see that? So no two employees have the same ID. Primary key is used to make sure that every value in a given column is distinct, is unique, right? This is very important. And then you're going to, if you take this column and put it into other tables, it becomes what we call a foreign key, right? So that's it for the business entity ID. So now you understand that description. The next one is the national ID number. If I go back to the definition, is this one right here, national ID number. It says it's a unique national identification number such as social security number, right? This is a number right here. And this one is also unique. No two employees should have this number. The login ID. So now you see we are able to use this document and have a better picture of what each of these columns is capturing. Login ID is the network login. So usually when you join a company, they're going to give you a login and a password. You can use that to access the company server, company information and stuff like that. Right. So this document is very, very important. Right. And this document right here, it talks about the hire date. Let's go look at the hire date. I'm just going to skip that, go to the hire date. Right, hire date. Or let me just talk about marital status. If you look at, or maybe this one right here, let's look for those things that are not very clear. The organizational note, where the employee is located in the corporate hierarchy. If you go right here, organizational note is this, and then they have an organizational level, right? So you can see this from a much more better perspective. The depth of the employee in the corporate hierarchy. We're going to use this column in the next table, in the next question. Now, hire date, if we're contemplating what hire is all about, employee hired on this date. Yes, so we need that information for this question too. When did this individual join the company? That is a hire date, right? So all we need to do, this is the query we've built so far for that particular individual. All you need to do now is to add hire date, right? This is when the employee, that particular individual, joined the company. And if you can project this so that the information is complete, we know the name of the CEO, their job title is right there, and this is when they joined the company. See that? If you ask maybe to find out how long the CEO has been in the company, you can use the date diff function. Right. So when did this person start working for Adventure Works? This is supposed to go to the next one. So we see it's a continuation of the same thing you're building. Just simply have to add this to the list. See that? Now by adding the hire date column, you're going to be able to access that information. When did this person start working for Adventure Works? This is the hire date right there. Right. There could be a second part to this question. How long has this person been in the company? You're going to look at the date diff function. Maybe I'll transform this into an E, A, B, C, D. Let's transform this into D. And I'm going to add this right here. How long has this person been in the company? How long? So that has this person in the company, and the company is what Adventure Works. Right. So this is the duration. And they want you to compute this in years. Let's calculate how long this person has been in the company in years. So that's the C part. It's still gonna be an extension. So if I just put it, this is B, let's go to C. It's just gonna be an extension. Right. So it's the same query, we keep adding information to it. So if I put that information right here, we already have the hire date. So we want to look at the number of years from the hire date all the way to today's date. That will be the duration. So how do we calculate duration in SQL? This is very important. You don't take this hire date minus today's date, or today's date is a bigger date. You can put today's date. How do we get today's date? It's the get date function. Right. If you want to get current date and time, it's the get date function. So if you add this column right there and see what we get. A new column has been added which prints out today's date and time. That's this function. All right, so this is a revision. If you want to print out the current date and time when you're doing any analysis in SQL, use the getDate function. It takes no column, no parameter is passed into this function, no expression. That's what it prints out. If you take the difference between this date and today's date, it will tell you how long that person has been in the company. You see that? All right, so if I go to the next line, for example, I want to do the difference between this date. Let me show you what you are not supposed to do in SQL. Other SQL language will support this. You can take 2 days and just subtract them like this. See that? If I run this, see what we get. See, the data type are incompatible in the subtract. This is just because this right here is showing date and time. This is just it. But this is not how you do it, right? We use the date function. That is the function you use when you want to look at the difference between 2 dates with the goal of calculating duration. So that's how you call the function datediff. We're told to calculate the duration in years, so this part right here is very important. Whatever you want to calculate will be quantified in years. That's why we put year right here. And then we start by putting the start date. Start date is, in this case, is when the person was hired. You're going to put it like this. And then followed by the end date. The end date is as of today. How long has this person been in the company? So this is what we call the start date. This is the end date. And the datediff function will take the difference between these two, and that result will be read in years. If you want to compute the difference in month, you're going to put month right here. You have to understand that 10 years is different from 10 months, is different from 10 days. See, that's why we have to quantify it so that the system knows how to calculate. See, so if I put year right here, we are telling the system to look at the difference between this date and this date in terms of what? Year. And so if I run this, see, it is 15 years from 2009 to 2024, right? So now this gives you the duration in years. I don't need this column anymore. That was just for the demonstration, right? And this right here, we're going to call this duration. This is a new column, duration, and you can better quantify this in year so that anybody, and all of this, I need to force this into a square bracket, right? You see that? So we are still on that same individual, the CEO. We know the name of the CEO, we know their job title, we know when they were hired, and then this is a new column we've created which calculates the number of years they've been in the company as of today's date, right? So this is just a revision of the datediff function. We're still going to see it on another example. Let me copy this and share with you all. And please, if you see anything strange or you need more explanation, just draw my attention, especially those who missed the session over the weekend. This is an opportunity to review and understand this. So far we've talked about 2 key functions, concat. You can have several different columns or expressions and you want to combine them together. Always think about the concat. And when you call each component, put a comma, call the next component, put a comma, and just like that. And the system will combine all of those for you into a single column. Any questions so far? want to show you a demonstration of the use of a concat function. I'm going to copy this and just put it on a different window. Imagine if we told to build a script which will introduce every single employee, and in that introduction, each employee will state their name, state their job title, and state how long they've been in the company. Right. This is very important. A brief introduction of each employee. Write a brief introduction of each employee. So all of this information will fit in one column. So you can just read it continuously. So with the following information, right? I'm going to show you, we're going to discuss the information that we're going to combine them into one statement, one sentence. So write a brief introduction of each employee with the following key information, All right, let's go first and last name. So in that brief introduction, you must state the first and last name of the employee. First and last name of the employee, must state their job title, and then let's keep it simple, and the duration, or let's put hire date, or let's just put duration company. So these are the key information that the description will carry for each employee, and all of this information should fit on a single line, single column. See, for example, we know the CEO. I'm going to put an example right here. For example, the CEO, we did this individual. So we can begin by saying this information for the CEO. It's going to read, my name is, you're going to fetch that information, the name, you see, put the name right here. I am put this information in that spot. I am the Chief Executive Officer. That's the job title. The next part is going to read, it's a continuation, right? I have been, and that calculation, this is it right here, for over 15 years. You notice that some of this information is going to be fixed for everyone, but others will keep changing. So for you to draft this thing, you have to know what is changing and what is fixed for everyone. So now we can use this query. It's going to be a SQL statement. And let me show you how we're going to build that. It's going to be a SQL statement, and we're going to build that together. All right. So let me first of all fetch all the information we need. We're going to separate them. So I need this first and last name. Can we put a concat within a concat? Yes, we can do that. Let's back it up in this. Yes, we need this information. I don't need this. I'm going to take this out. So we need this information. This is the information right here. You see, this part we need it, right? And then all of this, my name is going to be the same for everyone. This is going to change since they're different employees. I am there. This is going to change. Chief Executive Officer as a job title. We need this column to print that information for this. I have been with the company for over 10, 15 years. So this is going to change. Every other thing in this sentence is going to be the same. So the key things that is going to change will be, I don't need this part right here. So these are the three key things. This right here will generate this information right here. It's going to change for every employee. This right here will generate this, which will change for every employee. And then this right here will generate this, and every other thing is static. Static means it's not column driven. You don't need a column to put that information. Now, having identified that, so we have two sets of expressions. This is what? Static. It's never going to change. And let me show you how you code a static information. Just copy this information, that's the static part. And now we're just going to put it right here. So everyone will have this. My name is, this is static. See the way I've coded the static information. Now, and I'm going to put a space right here so that we have a space between my name is and the title, the job, sorry, not the job title, the name, which is this information right here. You see what I'm doing? I'm already aligning the way this thing is going to read. So it's going to begin, my name is, it's going to pull this information and fill it right here, followed by what? A full stop. So I need an expression to bring in a full stop. Right. And how can I do that? I can just put a string environment right here, put a full stop. And after the full stop, we'll need a space. You see this space right here? So I can use one environment to capture that. You see that? So I'm building the separate components. We started with this one. My name is, this will bring in the name. This is column driven, right? Next, once that name is fitted right here, which is this expression, all the way to this, we need this part right here at the end of that line, you see, which is this right here. I am there, this is static. So the next line is going to read, this is static. And in a static environment, you have to put this. See that? This brings that part. This is what dynamic, that's a job title, which is this one. See that? And then what next? It follows a full stop. Full stop, which is the same thing we did right here. I can just copy this information and put it right here. See that? And then the next line will read, I have been with the company for over, this is static, it's going to be the same for everyone. I can put that on the next line as a string. This is static information. And then over, you see, after over, there is a space. I can just put a space right here so that the year part, which is this calculation, will follow. And at the end of this year part, we're going to put these years, which is another static information. So we need a space and then that information. See, so I will just go to the last line and just put that as a string. What function can combine all of these into one? So for a start, if I just comma separate all of this expression right here, comma separate, go to the next one. Right, we need to bring in the concat function to combine all of this into one. And after this, there should be a full stop right here. So we can just put it right here. See that? So this is where things become interesting. You want to make this easy, just put a concat function and see how this works. The concat function starts with this, it follows expression by expression. So it starts with this expression. After every expression, there's a comma for the concat function. It goes to this one. This one ends right here. It gets a comma. and then goes to this one. This one ends right here. Let's put a comma. So remember, in a concat function, after every expression, there's a comma. So this is an expression. It ends right here. Put a comma. It goes to this, states the job title, that's a comma. States is a dot, full stop, and a space. That's another comma right here. And then I have been with the company for over. This is an expression right here. Put a comma, and then we're going to compute the year. Put a comma right here, and then state this. That's the last expression, and then you close the parenthesis. So you see the concat function starts right here and ends right here. If you want to take this to the next line, that's fine. See, this is very important. You see, and now if I execute this, see what happens. Everything that is meant to change changes. See, it's simply now calculating that information that we've coded them through columns is fitting them. Right, this is very important. So this is an introduction of every single employee. There are 290 of those employees. Right, I'm going to give you the guys, this is an assignment. You have to, let me just share this with you. It's something very interesting. Right, this is just shows you the power of the concat function. And you just have to follow you can type all of this in one line. It's not an issue. This is not a syntax violation. The reason I spread this out is just to, so you can see the flow step by step, how the expressions are coming in, how each component is being built. First, you have to understand a static component from a dynamic component. Dynamic ones are column driven. So you need a column name. This is static. This is not going to change. This is the same opening statement for each person. My name is this. The name part is this part, which combines the first and last name with a space. Then follows that with a full stop. You see, and when you execute this, you're going to see how each of those is coming. This part is the same for everyone. My name is all the static parts print out the same for everyone. Every row represents an employee. See that? So my name is, you see, at the level of the name of that employee changes. See, it keeps changing. You see, it goes to the next static part. This is a full stop. At the end of the employee's name is a full stop. It follows the same for everyone. Then we have a space. Then this next one. I am the, you state the title. See, for this person, oh, there is a mistake right here. If you look at I am the, and the title is all joined together. So you can go in right here. See how you bring in a space? Put a space right here. So that I am the, before we get to the job title, let's introduce a space right here. Now let me run this so that you can see the improvement. Right. That's why it's always good to build something and you check it. If you want to expand this, just pull across. Now you see it reads, my name is this, full stop, space. We had that already incorporated, full stop and space. I am the chief executive officer. Now there's a space between the, which is this static part. I am the space, job title follows. And then next, we have a full stop after the job title. We have a full stop and a space. Yes, we are taking the provision for that. Full stop and a space. I have been with the company for over 15 years. See, this is static. I have been with the company for over, and we had a space. This computes that duration and fits it in there. You see, it changes based on scenario. See that? If you want to put some other stuff like, my name is this, I am the chief executive officer, I can just add another line right here. I was hired. I was hired in. Now this will follow the hire date. See, for example, for that very first person that person was hired, I will need to show the hire date. See, so this component right here will now find its way after the job title, which is this. So I will now feed it right here after the job title. I will feed it right here after the job title, a dot and a space, and then I'm going to put this as a string. This is not column driven, this is a static. I was hired in. I have to put a space so that the higher year will now fit. I can now add the higher date. See the concatenation process. Call in the higher date. I need a comma right here so that I can identify the column I want. Higher date. So if I put the higher date, see it now follows. I was hired in. The higher date will print the date that employee was hired. We are doing this per row for each employee. Now after this, we're going to continue with a full stop and a space. So we need this. See, after every sentence, we have a full stop, and a space, and then the next one follows. See that? So let's run this and see the update we've made. So we've added the year, the date the person was hired. Let me just expand this. So for that chief executive officer, they were hired in this date. See right here, was hired in this full stop. See that part? Now I can just copy this, and that's exactly the sample message I was trying to build right here. This is a sample message for one employee. See, my name is this. I am the chief executive officer. I was hired in this. I have been with the company for over 15 years. That's just for one person. The next person comes in and reads something different. Right, the higher date is this. Been the company for, see that? This is just to highlight the power of the concat function. So if you're working in any project and you're asked to combine things like this, first of all, know which is the static part, and the static part is always just hard coded like this. And then the dynamic part are areas that will keep changing based on the individual, based on the employee. Those will be column driven. If you need to do some logic on them, you do it. You see, I will share this. This is something interesting. I want you guys to create time and just, this is an example to show you, just demonstrate the power of the concat function. And it is really, really simple. You have several expressions. You want to combine them all into one statement. And always remember the guiding principle. There must be a comma after each expression. And that is exactly what we've done right here. I'm going to pause for a little while. I think I will add this question right here on the list. Let's go back to this. So C will start, and this is going to be D. So we've taken this concat function to a different level, you see, and it is really, really interesting. You can play around with stuff like that. See, and so for this one, we are doing it for every employee. That's why we've kicked out the where clause. See, this is printing out this information for every single employee, all the 290 of them. And you can always remember to expand like this, and this is information, right? Okay, this is really interesting. So please remember to use as an example to further understand the use of the concat function. If you look at this D, who reports to the CEO. If you want to understand this, you have to go back to data dictionary. All organizational level 1 employees report to the CEO. It gave you a clue right here. All right, so who reports to the CEO? Everybody in organizational level 1 reports to the CEO. So if you simply go to that table, either this or this, I think it should be this one. There is a column called organizational level, and you have one. You see, this is a CEO right here, business entity ID 1, that's a CEO. This person does not report to anybody, that's why it's null. You see, chief executive officer. So everybody in organizational level 1 reports to the CEO. This is a hierarchy in the company. Those in level 2 report to those who are in level 1. Those in level 3 report to those who are in level 2. Right. So every organization has the org tree, the organizational tree from the top all the way to the lowest in the company. So you can know who is whose manager, who's all the employees, where they belong. In a big company, you're going to see that organizational structure. Right. It's a hierarchy from the top to the lowest. So if you want to answer this question, you must understand this. And if you go to this data dictionary, it says organizational level. That's the column you're going to use. The depth of the employee in the corporate hierarchy. See? So it goes from 1 all the way to the number we saw right there. So all those who are in level 1, they are answerable to the chief executive officer. See? See, level 1, like the vice president, all those vice presidents, they are in level 1, they are answerable to the CEO. Now, those in level 2, the engineers and others, they are answerable to those in level 1. So this was a good clue so that you will now use that column and point it to level 1 and say those are the employees who report directly to the CEO. So who reports to the CEO? So every one of these employees. So in this case, we just have to dismiss the where clause, move it away from that condition and put a new one, which is the organizational level equal 1. And that will be the list of all the employees who report to the CEO. So this is the D, this one right here. So we need to just change this. This now has to read where organizational level is this equal to 1. So all organizational level 1 employees report to the CEO. So this will now be the list of employees who report to the CEO. See that? So there are 6 of them. If you look at, you're seeing those vice marketing manager, vice president. Yes, these are level 1 employees, and all level 1 employees report directly to the CEO. All right, so this question needed some inside knowledge about the business. I tried giving you a clue on that by putting this right here. All organizational level 1 employees report to the CEO. And if you just go to the data dictionary under organizational level, it tells you the depth of the employee in the corporate hierarchy. Right. And if you look at the CEO, does not report to anyone. So if you go check out that information for the CEO, they do not report to anyone. Their organizational level will be null, missing. Right. You can go maybe to one of these. This is the CEO, right? Just add another column right here, organizational level, and you see that for the CEO, the organizational level is null. The CEO does not report to anyone. Then everyone now in level 1 report to the CEO. All those in level 2 report to all those in level 1. Report to those in level 1, you see? Right, so let me remove this. Now you're getting to understand this database, the different tables. This is becoming very helpful. This is what we call a data dictionary. Right, this is one of those important documents. When you join a company, you can ask. I guarantee you that not every company has a document. So you have to keep asking questions on the business side to clarify concepts about the project you're working on. So this is the only thing you're supposed to do right there. And this will give you now the list of employees who report to the CEO. Any question on this? So the condition was just to put organizational level equal to 1, and you have that outcome. We've spent a lot of time on question 1. Yeah, but let me try to speed it up. So in this question 2 is the same database, we're going to be using this data, this and this. So guess what? We've already joined these two above. So we can just go and copy the join statement, which is this one. It's the same table. We've already joined them. And that is what we're going to use as the base for this next question. Right. So if we already have that base, this is it. You can just run it so you can see the columns we're going to be dealing with across the two tables. So yes, so there are 290 employees that work for AdventureWorks. See, if you combine this and this, run it, and you see that there are 290. Yes, that's valid. And if you stay on just the employees table, it's still going to give you the same information, 290 employees. When you're reading the question and you see some statement like this, you have to fact check it. You have to confirm to make sure that yes, you can see 290 employees. Right. Now, leadership would like to wish their employees happy birthday on their actual birthday. So write a SQL statement that will give a list of all 290 employees, full name, birth date, and age. And the age. This is a calculated column. Every other column is available. For the full name, we know what to do. We're going to combine first and last name. We've done that part already. This is it. Combine the first and the last name. That's a concat to get the full name. This is it. So we've done that part already. I'm just going to put it right here. That's the first column. See? The birth date. Yes, we can pull up the birth date. There's a column called birth date. This is it right here. That's the birth date. And then the age. This column will be calculated. How do you calculate age? Please remember this. This is a duration. All right. So we're going to use the date function. This is the second time we're using this function. All right. And we're going to be calculating this age in years. It was not specified, but we just go for years. So this will be the first thing you put. Now, what is the start date? In the date function, you have three requirements. You have the interval, you have the start date. In this case, is the birth date. That's where we begin the calculation. Start date, and then the end date as of today. How old are these employees? So we're going to ask the system to give us today's date through what the get date function. See, so we're now going to look at the duration from birth date to today's date, and we're going to express that in years. And this column is what we call age. That's a new column. And then if we execute this, so for each employee, show me the first and last name. That's a concat process right there. Show me their birth date. This is just a straight column we are pulling from that employee table. And then show us the age. This is a calculated column because we are using the birth date and today's date, and we are looking at the time interval in years between those two events, and that will give us a concept of the age. Right, this is very important. This is the second time we're using the date function. So please take note, duration, calculating duration in businesses, the date function. Right. So this is the part, this is A. Right. I think we've achieved the requirement for that question. That's it right there. Let me share this. Right. Please, this is an opportunity to review these functions. Right. Just make sure you ask questions so that I can clarify the steps. Right. So computing the difference between two dates, always remember date difference between two dates. It's a date function. So we're still going to need this query for B. All right, so I'm just going to copy that stuff with date right here, change this to B, and then there's something we're going to add a where clause. Yes, that's a condition that will use the get date function to limit employees with birthday in the current month. How will you code this? The birth date should be in the current month. In the current month. For example, if I show you this, if I run this, What's the current month? The current month is February. So all those who have February, for example, this person's birthday is in this current month. So this is February. So we need this person. And you just keep that. You see what I'm checking? I'm just checking to make sure that the month is February. Why? Because the current month is February. See that? That's what we have to do. So how are we going to code that? So the focus is what? The month. See? So you have to investigate instances where the birth date, the month of the birth date is equal to the month of today's date. And how do we get today's date? It's get date. So I'm showing you the crude method. This is not what you're going to do. The emphasis is on the month. This is you just comparing two dates. Right? The emphasis should be on the month. Right? This is it. Add a word clause that we use the get date function to limit employees with birth day in the current month. What is the current month? The current month is February. And if I was just to write a non-table based query to get the current month, I'm just going to put select month and I apply that function on this one. First of all, let me start. This gives you what today's date and time. If I just want to drop everything and just get the month, there is a function for that. It's the month function. Right, so let me show you the reasoning a little bit outside that environment. Use the month and then subject that month function to this. This is returning this. So instead of taking this is what we call static coding, right? This can change tomorrow or next month or whatever. So instead of returning that value, use the function that generated the value. And this is what we call dynamic coding. See? So this right here will go into that expression that is returned from the get date and select the month only. It's the same thing right here. This is hard coding. It will go right here, skip, and just return only that. That's the month. So that's the logic we're going to use. See? So instead of putting this equal to this, the focus is a month. So we're going to use the month function on birthday. All right. So whenever the month of the birthday of the employee is equal to the month that we extract from today's date, then that employee's birthday is due in the current month. See, that's the investigation we're going to do. And you see, 25 employees have their birthday in the month of February, which is the current month. And that's the same thing you see. Just check the middle part. This is the year, the month, and the day. So if you just scan through, you see that all of these employees, their birth date was in February. So their birthday will fall in the month of February. That's the current month. This code right here is valid for any given time. That's why we call this dynamic coding. You don't have to change anything on this. Any next month is going to run and pull up the current month, which will be March, and then March, compare the left and the right hand side. This is what we call dynamic coding. Right? You see that? So this is how you can generate a list of employees whose birthday is due in the current month, and you can send this to the HR department. For those who do HR analytics, these are the kind of things they do. So at the beginning of every month, the HR department wants to know all the list of all employees whose birthday is due in that month. Right? Some companies they send you a happy birthday message on your birthday, but they have to plan ahead of time. So this is going to be the full list for the month of February right here. You see how we can use analytics to get this. The only thing you should focus on is the logic right here. And you have to understand, go back to the question, that's where everything begins. Let's add a word clause making use of this. They want it to be dynamic to limit employees whose birthday is in the current month. So this is what you will do. This equal to this. And if you look at the full list of 25 employees, all have one thing in common. They all born in the month of February, which happens to be the current month. So if the birth month is equal to the current month, then this is a list of employees whose birthday is due in the month of February. The next question is a little bit very specific. Let me share this first. Yes, the next question is a little bit very specific. Only show employees that have a birthday today. So we started with the month, and then they want you to zoom and be more specific all the way to the day. See that? So this one was kind of general, focus the current month, which is February, and everyone is right. But let's zoom in and just those whose birthday is due today. What's the date of today? Today is, if you use your get date function, you pull up that information, select get date. Of course, this is tied to your location. So this is the 21st of February. Go back to that list and see if, and an easy way to do this is actually to order by birth date. Right, so just throw an order by right there, order by this. And let's run this. So, and that's normally how you're going to present this to the HR department. You want to arrange them in the order in which they occur. This is going to be, it's a little bit messed up. Let me take this down to see. So order by birth date. Let's put this ascending. And let's see if, okay, so this is, since we don't really care about the year, but we care more about the month. So in this case, instead of ordering by the full year, the full date, you want to do something very specific. You want to order by the month. This part, and there's a reason why. Right. Let me show you how this is going to be much better. The HR department will appreciate this layout better than the one on the year. See this right here. We don't care about the year. We are focusing on the month. But anyway, everything is the same. So the best way to sort this would be on the day. Switch this to day. Ignore the year. The month is the same for everyone. It's February, current month. But then what is interesting now is the day. See that this person is top on the list. We're going to say in the month of October, we're going to celebrate this person's birthday first, followed by this. These two are going to be on the same. See, followed by this. We have this people. We're going to join them and celebrate their birthday. See, that's why I had to go in there and do an order by the day. This already kicks out the month because we are zooming into the month of October. Right, so you cannot order by that. I started off by ordering the birth date. The year factor will come in and distort everything. We don't care about the year. We just want to make sure that these are lists of people whose birthday is during the current month, and then list them out in the order in which we're going to experience them. So this is how you sort it. It makes the life of the HR lady easy. See that? And then now, if you now see where the next question comes in. What's the date of today? Today is October 21st. Go on this list and see if anybody's birthday is due today, October 21st. None. We have somebody to next 2 days. See, so it tells you that if you want to condition that in a where clause, we're going to remove. Yes, we're going to keep the month. Next, we're going to add another condition on the day. See that? So condition on the month and then bring the day, which is this one. So this right here, we're going to do it also for the birth date. The day of the birth date should be equal to the day of the current date. So this one will be applied to the get date, this one. I don't know if this is making sense. You see that? This one we are conditioning on the month. The month of the birthday should be equal to the month of today, which is what? February. Also, the day of the birth date should be equal to the day of the current date, which is 21st. So with these two conditions, like we investigated before, nobody qualifies. Right, and it's easy. You can actually go back. If you dismiss this one, go back and check for yourself. This is a list of all those whose birthdays during the month of February, and we've sorted them. See, nobody falls on the 21st. See, so now if you bring back that condition, you see this is it. Are we okay? So this is how you're supposed to answer that question. See, only show employees that have a birthday today. I'm gonna share this. Right, that's question two. Please, if you need me to review a question, just draw my attention to it so I can repeat the logic. So the most important thing problem solving is the strategy, the logic. What logic are we using? This is all logic driven. See, I state something, I explain it to you, and then I show you the result. You can see for yourself that yes, the logic is actually working. See, and also the sorting. You have to understand why we are using the date, the day of the birth date. Right. I'm going to go to question three. I think with this, you can solve this question. Calculate the age of every current employee. It's the same thing. We've done age already. But then this time around, you're assuming that this is the current date. See? So you're not going to be using get date. All right, let me just copy this and show you the modification you're going to do. It's a continuation. What is the age of the oldest employee? Okay, anyway, let's just go ahead and do this. So this one right here, I'm going to dismiss a couple of things. We don't need the where clause. And we're going to modify the way we calculate the age. They want us to use this as the current date. So assume today is this. And this is one thing you will not do. You're not going to copy that and just put it right here. So from the birth date to the current date, which is assumed to be this, what is the age of that employee? You see that this right here is stated in the year, month, and day format. See that this is very important. Let me remove this part so that I can highlight that concept. We have to bring the next date to mimic that. You see, year, month, and day, and check the format. So you cannot just go and copy that stuff and just add it to your code. You have to translate this. All right. August, that's the 8th month. So we have to transform this into what? 2024, 2014, sorry, 08. And that was 25, right? 25 or 15. Let me just check. August 15. So this is 15. This is the correct way you're going to do this. So you see how we translated this so that it is in the same format as this. This column has values projected like this. This is very important. Right. So that's the only thing you change. The logic of the age calculation is the same. We are going through the date diff function. This is the start date, that's the birth date, and this is the current date, that's the assumption in this question. As of today, assume this. Right. And then this right here will be that calculation. We are showing each employee the age. See that? Then we're told to return some specific columns. Yes, return the business entity ID, first and last name, age. We already have the first and last name combined together. Let's use the business entity ID. And this column is going to be an ambiguous column because it's present. See, it's present in the employee table. It's also present in the person table. Anyone you choose is not going to be a problem. That's an inner join, is matching. Right? See that? So this is it. So that is for this question right here. So that's another way to calculate age. What is the age of the oldest employee? And then they want you to preserve the same structure. Right? Can somebody tell me how I'm going to just project the information for the oldest employee? It's easy. We're going to order by the age column from the highest to the lowest, so that we have the highest or the oldest employee on the very first line. And then now, how do we extract that? So let's do it step by step. So the first thing is sort. So first, let me copy this. This is the A part. I'm going to put this below. So first thing we're going to sort. Sort by what? Age. Age is an alias. Yes, you can order by an alias column. So this is very important. I want you to observe the steps I'm going to be using right here. We just want to show the information of the oldest employee. So only one row. Right. So right now we are having all the 290 employees. We've sorted them based on age. This person is the oldest. This is 62, all the way down to the youngest employee, 23. You see that? So let's go back to the top. What can you do to return only this row? That's the oldest. And you remember something they call the top one. Once you've built your structure using the order by, you can now go right here. Instead of getting all the 290 employees, we just want one, top one. Top based on what? Top one based on the age sorting. And this is the information you get, just one. And this is the business entity ID, the full name, and the birth date of the and the age of the oldest employee. Always remember this thing: top one, top five, top. It always goes with the order by. You have to begin by capturing the structure. Order by age. We want age to drive this sorting process, and you can clearly see. And make sure you observe that the sorting is done correctly. The oldest employee is 63 years and the youngest is 23. Right. Now we are not interested in every one of the 290. We just want the oldest. And that's the first row. That's when the concept of top comes in, to extract the first row. And that is the extraction right there. This is the information for the oldest employee. See, this is very, very important. Let me share this. Right. So, and guys, you have to sit back and review this again. That's where the real learning is taking place. You're observing, you're building, you're understanding the strategy, but then you have to go home and redo this, do it over and over so that you understand this, the logic. Right. And that's how you build your experience. Problem solving comes with experience. You have to do so many problem solving so that you start understanding strategies into different questions. Right. It all begins by you understanding the question. There was something we are supposed to do on this age calculation. Or not. What is the age? Okay, this one right here. What is the average age by organizational level? This is the second time we're coming across this column. So for each organizational level, many employees can belong to the same organizational level. So what you're going to do is to group all employees that belong to the same organizational level, and then we calculate the average age. And then they want us to project that into a single decimal. You always have to understand the equation first. So in this B, we already have things we've put together. We can just copy this, and then we'll see what we can kick out so as to build this new equation. This is B. So this B is very simple. Show me each organizational level and tell me the average age of employees in that level. See? So the only things we need right here is these two. So this is me showing you the organizational level column, and then this is the calculation for the age. If I run this, I'm showing you each row of the employee. See, there are 290 employees. That's why we get 290 rows. But this is not what they want to do. All those who are in level 1, put them together, calculate the average age. All those in level 3, put them all together. That's grouping. See, that's basically what I'm trying to say right here. And then you see that this one is the individual ages, not the average. This row shows the individual ages, not the average. To have the average age, you must first of all group by the organizational level. So I need to throw in a group by. See right here, group by this. And then what do we do on this? We have to aggregate this, which is what? Average. So this expression is the age. I'm going to cut this off. I will introduce the average function on that calculation. That calculation is the age. Now this is what we call average age. And I have to update this to average age. See? Right. This is very, very important. I hope this is understood. This is now average age. Let me just put this. So we're not looking at just the age. We've calculated that age. We need to average over the age calculation. I need to put a square bracket right here. So now this is average age. And notice without a group by, you're wasting your time because this column is non-aggregated. Why this calculation right here, which is a calculation for age, has been aggregated. So if I run this without a group by, see what we get. We get an error. You have to put the group by. It is now going to show you each organizational level and the average age. This null is the CEO. The CEO had no organizational level. And see, so now this is the average age of employees in each organizational level, right? And this calculation right here, since this function always returns an integer, if you calculate an average over an integer, it will always be an integer, right? So you cannot see those decimals. But then if we now transform the calculation before we average, you're going to see something different. This is the averaging. See, let's transform this calculation into what? A float, a decimal. This function returns an integer. So this calculation will be an integer, whole numbers. So let's transform this into a float. So this is a conversion function. This is a function you have to know. This function will help you to transform an expression into a desired data type. Float will accept decimals. I have to do this first before I average over this. So this will transform that age calculation from being an integer into being what? A float, a decimal. So that now when we apply our average function on it, you see I always cut the expression so that I can type and understand what I'm doing. AVG, we can now apply the average on that expression. So always read this from the innermost part. The inner part is calculating the age. That's the difference between the birth date and this date, and it is expressed as a year. This is an integer. This part is an integer. Now we use a transforming function which is called cast, which changes the data type of this expression into what? A decimal, that's float. Now we can now calculate average on decimal so that we can now see the average, the decimals showing up. Always remember that the date function will always return an integer. You see those decimals are now showing up. Right, in the previous example, you see I do it in phases. In the previous phase, date is an integer. This expression right here will give an integer. If you average over integers, you get an integer, not a whole number, not a decimal. See that? Right, but then if we do an intermediate phase, which is changing the data type of this calculation from integer into a decimal as float, we can now calculate the average on those decimals and we can get decimal. See, this is always very important. And I always use this as an example to students. If you do a simple calculation like this, select 5 divided by 2. 5 is an integer, is a whole number. 2 is a whole number. This calculation will give you a whole number. You might think that SQL Server does not know how to do basic division. No, it understands. It's just a data type. See, this is 2 because this is all involving. See, it's all involving integers. So you must get an integer. But then if I step in, I use the cast function. It's a function that will help you to change data type. I want to cast this as a float. That's exactly what we're doing on the other side. So now I have a float, a decimal on the numerator, and an integer on the denominator. Decimals are powerful. They take over the calculation. See, I now have the correct answer. That's exactly what we're experiencing on this side. See, right here, if you just go ahead and apply average on this expression, which is an integer, you always stick to the integer. See, you cannot get decimals out of that process. Right. Now, if you do this, transform the integer into a float, that's a decimal. Then you average. Now you're averaging on decimals or floats, you get a float. See that? And now the next part comes in. We're told to return it as a single decimal. And then there's a function called round, the round function. So I'm doing this step by step. The round function will now go in on that calculation. This is the expression. Let's round this to, I always get it off first. This is the round function, round this. And when you put the expression, you now put a comma and state the number of decimal places. So I'm going to paste it. Now I can put a comma where my cursor is blinking. You see, this is a long expression. So if I put 1, it simply means round this answer right here. Everything is here into 1 decimal place. And now let's run this. See, it's now projecting it as 1 decimal place. You see, there's an improvement from what we got on this. This right here gives you everything. So many decimal points. Just one decimal point. So that's one way. There's also a function called format. So I can copy this expression. No, not this one right here. And I can show you an example using the format function, which is also very, very interesting. So in this approach, we're going to use the format function. I'm just going to put it next to this so that you can compare. So format, this is how that function is stated, format. You put an expression, we're going to paste it right here, put a comma, and you put this n is for number. And then 1 means 1 decimal place. So I want to format this expression. I'm going to paste the expression. I want to format all of this expression right here into a number, 1 decimal place. You see? So that's how the format function works. You see, it is beautifully done. You see, the round function missed out on 45 because 45 came out without any decimal. This is just one person's age. There's only one person in this group, the CEO. Right. And if you want to know the number of employees in each group, each organizational level, this is just something you can add. You can just do a count. Remember that each employee has a business entity ID. So if you want to count the number of employees in each organizational node, that will be the count right there. And if I run this, see, this is only one person in this group, and that's their age. There's no averaging on this. There are 6 employees in organizational level 1. We add all their ages and divide by 6. There are 27 employees in organizational level 2. We add all their ages and divide by 27. That's how the average is calculated. There are 66 employees in organizational level 3. We add all their 66 ages and we divide by 66. You see how those decimals are coming in. So now you understand why that first one, the null, is just one individual and that's their age 45. Averaging on one value is the same value. That's why that one did not pull up a decimal. But then the format function was able to do some maneuver, and you could see it brought it to a decimal by just putting a zero. See, this is really consistent. The round function did a good job for this, but not this one. And most managers want things to be very consistent. If they ask you one decimal place, they want you to do across the board. So if you're using the round function, it's giving you headache. This will never fail. The format function will always deliver. Right. So that's how you're going to do that. Let me share this. I will share this entire script. Maybe, yeah, just don't bother. I will provide the script. Right. There's one question that we needed to solve. This and this, I'm just going to combine the two. Use the ceiling function. Remember, is to round down, to round up. Sorry, ceiling is above. So this is a round up function. And then the floor function does a round down. So I'll use both on that age calculation, average age. So we use a round, we use the format. I'll change this to this, the ceiling and the floor so that you can see the difference. All right, so I'm going to add two functions on this list right here. So always target the expression, the average, all that concept formatted this one. Yes, this. So we're going to apply the, let's begin with the ceiling function. This is a function that does round up. So let's round up this expression. That's the ceiling function. And the comma right here. See, and then the next counterpart will be the floor. This is a round down. And I'm going to show you the behavior, how it's changing. So just change this to floor. Right, these are functions that are similar to each other. This one is rounding up, this one is rounding down. And I'm going to show you now the example. Remember, the original is this average age. This is what we get when we use the round function. In fact, let me just go with the title so that you can see. So we have the original age. This is what we get from the round function. I'm just going to type fx and right. This right here is what we get from the format function. Let me check. Yes, that's a format function. No, this is round. Sorry, round. This one has to go. Okay. So I want to do an explicit work right here. I will remove the round function. This is just the original average we got without any function. Remove this. So this will be the average we got, right? Now this is average using the fx function, the round function. I'm going to put it right here. And then we're just going to follow through with the names. The next one is this. This is using the format. And the next one, that's the ceiling. Then we get to the floor. Yeah, this is the ceiling. Before I send out these notes, I'll add some descriptions so that you can follow through the lecture. Then this is the floor. So this gives you an ability to see how each of those functions are operating. Right. So I've kept the original calculation as the average is this one. And on this average, yes, we had already done the float. Okay, yeah, so that's the original one. We've it already transform it into a decimal. And then this is what we get using the round function. So we're using the round function to one decimal place. You see, all of this is projected to one decimal place. This is not a decimal, so it just kept that the same. But see, the format function came and did a better job. It delivered on everything that the round function did, but then on this one as well, one decimal place. So it's consistent. Now see what the ceiling function is doing. This is 4.45.0. You can actually test this on, get the number 45.0. These are things you can do while you're studying, right? And then apply the ceiling function to that. Ceiling. I'm missing something right here. Apply the ceiling function to 45.0 and see what it does. So if you want to get the correct answer to this, you have to take this 45.0, put it on the number line, specify the next integer closest to 45. 45.0, the next integer as a whole number will be 46. That's on this side. Now on the below side, the next one closest to 45.0 is 45. When you have this, it is very important. This is what the ceiling function, the floor function will give. The floor function rounds down a number to the nearest whole number from the bottom, from below. That's ceiling, the floor, sorry. That's what the floor does. Why the ceiling round from above? So we call this round up, we call this round down. All right, so floor is round down. So round down 45 to the nearest whole number from the bottom. It's going to give this. You see the 45 right here, because that's a floor function. Round up 45 to the nearest whole number from above. After 45.0, the nearest whole number from above is 46. So the ceiling function gives this. Why should ceiling be targeted? Let's see. 45. Okay, this, it does not involve significance. If you're doing a round function, that's when it's going to push it to 46. So for the ceiling function, it doesn't evaluate the significance. Let me show you something. If I copy this, change it to a round function, let's round this to one decimal place, put a comma. For the round function, you need to provide the number of, let's say I had a 5 here, see, or I had a 4.5, 45.5. So this one takes into consideration the significance. This is 5, it's right, it's greater than or equal to 5, so it's going to promote this number into a, round this to one decimal place. Sorry, one decimal place. Let me put this right here, 6. So it is going to give you 45 point. This is not 5, but this is 6, because this number is above 5, so it's going to add it to this. So that's the logic of significance. See, instead of giving us 45.5, it assesses this value and is above 5, it promotes this 1 to 6. If this value is not up to 5, it will not promote it. So if I put something like 1 right here, this will give us 45.5. It evaluates this is not up to 5, so it stays 45.5. See that? So when it comes to significance, it is applied on the round function, but the ceiling does not. This is just so that you understand this part. Right, so ceiling and floor for this are the same. It stays on 45, and then this one also, ceiling, stays on 45. right? So the significant aspect comes in when you're looking at the round function. Anyway, we can better see it right here. So if I run this, you see the behaviors across the board. So ceiling and floor, they are still hitting 45, 45. And then for, maybe that's because this is 0. If I go take this, that's the ceiling. If I promote this into a 1 right here, and I do the same for the floor. Okay, it makes a difference right now. See? So if I put this on a number line, after 45, we are 0.1. The next whole number after 45 from above, this is 45.1. The next whole number will be 46. This explains why this will push it to 46. Now, if we stay at 45.1, the next whole number from below, it will be 45. So the floor on this one should give this 45. Let me apply this logic. Yes, it was already a little bit confusing when it was 0. It all resulted to the same. So ceiling and floor when it's 45.0 results to the same. Yeah, that's right here. But once you move away from the 0 by adding some decimal, this is the number, this is where you are. The nearest whole number from above is 46. It can no longer be 45 because you already have 1 decimal point above the target. So it goes to 46. And then for below, it's going to be 45. See that? So yes, this justifies that. You can use this static, this non-table based queries to actually fact check those. So this was the goal of this question, to show you how those different functions will act on this column right here. Rounding to 1 decimal place, formatting to 1 decimal place, applying the ceiling function, applying the floor function right there. I will add some comments on this lecture materials before sending them so you can understand what we're doing. There's one, I'm going to skip this question. You guys will solve this question 4. I want to address this one, which will, yes, let's look at this question 5. So using the sales order header table, there's a table we're going to use. I'm just going to put it right here. Select style from that. Let me use the next 10 minutes to solve this and we can discuss any issues. So this is it. So that's the table we are using. And now let me go back to the first question. Perform a total revenue. So you're going to be using the total due. Total revenue analysis per quarter and year for the year 2013 and 2014. So I already have a condition right here. Let me just go. The condition is for us to limit our analysis only on the year 2013 and 2014. And they say use the order date for this analysis. So we have the order date. We want to focus only on orders that came in for 2013 and 2014. Right. This is something you're going to need the year function. See what I'm going to do? I don't need the full date because I want to limit this analysis only to the year part 2013 and 2014. So I have to take the order date and transform it. So those who miss the class, this is it. You have to take the order date, transform it, and make sure, since there are two values, we use the in operator and make sure that we are looking at other years that came in for 2013, 2014. This is very important. You see, if I run this first part, how many orders do we have? We are dealing with 31,465 orders. Now, if we limit this to only orders that came in 2013 and 2014, see, we are down to 25,943. See, and if you go through that order date, you will see that all these orders, they are either in the year 2013 or in the year 2014. That is a filter we've applied. Yes, which is in line with this part of the equation right here. So what are we trying to target? We are now asked to show the total revenue per quarter and year. So in the date hierarchy, the highest is year. So I'll show you the year. So when dealing with date, the highest hierarchy is year. After year, you can go to quarter, and then you start going down all the way to the lowest level of a date. Right. So this right here will be the order year. You want us to begin with quarter. Right. So let's first of all get the quarter. Anyway, let me just put this. So this column is what will generate what we call the order year. So I'm putting together the columns we're going to get. This will be the order year. Right. Please take note. To get the quota, you cannot use the function quota which does not exist. That's the reason why I'm adding this kind of question to this, to teach you how to extract the quota. This does not exist. See that you have an error. For you to extract quota, you have to go through a function called date path. So you have to put date path, and then you specify the path you want to extract, which is quota. I want to extract quota from this date, order date. Yes, and then this is what will give you that order quota column. So I can put it right here. If you want to extract the year, there's a direct function called year. We've also seen a direct function called month. If you want to extract the month, you can put it right here and just put it on the column. Day as well. But if you want to do any other one, you have to go through the date path function. So the only three things you need to know: you can extract year directly, you can extract month directly. You see, it doesn't give you any error. You can extract day directly. It doesn't give you any error. Any other one, you must go through the date path function. For example, quota. You cannot apply quota directly right here. You have to put date path, quota, and then you extract the quota from this column. So these are the columns we need. There's one more I'm going to add, but before I add that, see, it is going to each of those and it is extracting the respective information. So how do you get quota? Quota goes from 1 to 4. The first 3 months on the calendar belong to quota 1. So January, February, and March, quota 1. I think you all know that information. If I add, let me just add this information to that so that you can see the flow. That's the order date. It gives you the full date. Go into this date and extract the year. This is what we did, 2013. Extract the quota. This is what January, February, and March belong to quota 1. See? And then the next 3 belongs to the second quarter, next 3 to the third quarter, the last 3, fourth quarter. That's how you get that quota stuff, right? What is the next thing you're missing right here? The total revenue, which is what? Summation on the total due. So we have to apply the sum function on the total due to get what we call total revenue. Right. So I will apply sum function on this, and that's how you end up getting the total revenue. Right. So this is what the total revenue is all about right here. So we've been able to isolate the 3 columns that are needed in this analysis. This column is non-aggregated. This column is also non-aggregated. So this and this must go to the group by. If I run this, it's going to fail. You have to understand that when you see an aggregate function, be careful, observe the other ones and put them in the group by. Copy this logic, add it to the group by. This is very important, group by. This. Copy the next one. If I run it, it's still going to fail because I've not put the other one. There are 3 columns, 2 are non-aggregated. So this is the second one. You see, I'm not copying the alias. You cannot use the alias in the group by. Right. So I'm showing you each quota for each year, and then I'm, looking at the total revenue. See, and if you want to really appreciate this nicely, you can sort on the quota. Let's go to. You can first of all sort by the year. Right. So let me throw my order by. It helps whoever is viewing this to see the years and the quota. Right. So first I'm going to order by year. So in the order by, you can use the alias. Right. You see, I could not use the alias in the group by, but I'm using the order by. So let's do ascending right here. Right. And then next, you see, if I stop right here, let's see the presentation. It's still messed. It's still nicely sorted. This is 2013, 2013, 2014. This question, I really wanted it to be 2012 and 2013. Switch this to 2012 and 2013 because I wanted to see the full quota, 2012 and 2013. Yes, 2012 and 2013. Right. So that when I run this, see, you're going to see the full picture. This is 2012, 2013. But then the sorting on the quota is not nicely done. So we have to also add quota on the order by. So that after sorting by year, go ahead and sort by quota, this one. Now you're going to make the life easy for anybody who is going to be visualizing this. So that we stay on 2012, which is this first, and we see the first quota, second quota, third quota, fourth quota for 2012. We go to 2013 and we repeat first quota, second quota. See, that's how you can sort across two columns to achieve this nice presentation. Doing one alone is not enough. See, so you understand why my order by now carries those two, and you can see the first four quarters for 2013, first four quarters for 2012 and 2013, and each we are seeing the total revenue generated. This is the analysis right here. So it always begins by you reading the question and understanding it. In a job, if you don't understand the question, you can ask the project owner for more clarification and stuff like that. So that's it for this question right here. Now they said format the total revenue in dollar amount. We talked about the format function. Where is the dollar amount total due? This is it. So this expression needs to be formatted. All you need to do is just extract this, bring in the format function. This is the second time we're using this format function. The first time we use it as a number. Now we want to use it as a currency. Dollar amount as C. So C is for currency, N is for number, and then we paste what we want to format. We want to format this expression right here, which is what? This total due, this total revenue, as a currency. Right, let's run this. Sometimes it's good to see the change that occurred by taking the original column, just add it to the list. This is just for you to understand what is going on. So we have the comma right here. I'm missing this. All right, so you see the original one was just total due, not formatted this one. And this is the one we formatted as a dollar amount. You see the difference. So this is the one they want you to keep, and we can remove this one. This is just to show you what the format function did. It transformed these numbers into dollar amounts. C is for currency, and the default currency is the US dollars. You see, this is very important. There are other ways to print the currencies of other countries, but I don't want to take you deep into that. Right? So just keeping that default US dollar is fine. So we don't need this anymore. We've now been able to format the value. Right, this is it. There is an interesting question right here to combine we're going to combine these two columns into one. See these two right here, we're going to combine them into one. And now we're talking about combining columns. What comes in mind? The concat function, right? They want you to combine the order quota, that's the first column, and the order year into a single column called year and quota, right? That is a concat process, and that is really, really simple, right? We've done this before. You can go ahead and start by dismissing the aliases. Just stay with the logic. Dismiss this alias. You cannot put aliases in the concat function. Dismiss this alias. These are the two expressions we need to put them in one column. So let's call our concat, open the parentheses. It takes the first expression, which is this. This is what? This is a quota, followed by comma. It takes the second expression. You can decide to put this in one line. Maybe that's going to help. Right, so, and then we close the last. See, please take note, this is the concat function. And now we've messed up that we no longer need. I will come back and fix this. Right, but let's just, this will simply mean using this logic. Let me just dismiss this for now. I'll come back and fix that. So what is the concat function going to do? It's going to combine this, which is a logic we use to extract the quota. It's also going to combine this, which is a logic we use to extract the year. And now guess what? You have to also realize that we've distorted the grouping. Yeah, this could still work like this. See that? In this, you are seeing the year and the quota. You're not going to, because we fused everything together, it doesn't look presentable. They want you to put a hyphen after the year, and then you call Q1. You put Q1. This right here is a quota. That's what we're getting from that extraction. So we need to put in that Q ourselves. So what's the first part? The first part is what? The year. This is an example of how things will look like at the end. All right, so the first part is a year. I think we have to reverse this. So the first part is a year. We have to remove this so that the first thing we get is a year in the concat process. This will call this. When you put the year, what's the next thing? All right, after putting the year, what's the next thing? You have to put a comma. What comes out next is the hyphen and the Q. So after you've put the year, call in a hyphen and a Q, right? And then the Q will be followed by what? The quota. The expression for the quota is this. This is how you extract the quota. And now you can close. I think the parenthesis looks good at this stage. Now, how many are open? One is open. That's why it's always good to build this separate and just copy and then dump it. I think I need something like this. Right, this is now good. So this is the first expression which brings in the year. And that's how you end up getting this. See? Now, how do you get the hyphen and the Q? The Q is the symbol for the quota. Remember, the quota function just gives you 1, 2, 3, or 4. You add the Q, which will now be followed by the quota. Let me stop here and show you what we've done. And see that it's close to what is depicted in that. See, this is a year, hyphen, and the quota. See, the Q is not coming from any function. It's something we've coded into it, the hyphen and the Q. No space, you see. But then these are the crucial part, the year, which we are using this logic to extract. We put this is static, and then we put this is the quota. So when you combine those two into a single column, this is what it reads. So this is the total revenue for Q4 of 2012. See that? And now we can sort them nicely by using this process we did. We can bring in the order, but I always want to keep the same format. And take this. I'm going to transform this into an order by. Of course, then we need the group by. So in the order by, first let's do sort on the year, then follow that by the quota. Then for the group by, we need this. So the structure of the group by will change because I've modified the structure of the columns, which are non-aggregated. So you have to understand why I'm bringing this. Is the first one right there. And then the second one is this formatting, which is aggregated. So we don't have to go by that. And that's the end of that process. Let's run this. Oh, just a moment. I get a column sales order is invalid in the order by. Yes, this column becomes invalid in the order by. The simple reason. So let me go back to this. Let's see, we have this. Yes, let me preserve this. And then from this, we can bring in the order by. So first thing we sort on the year is followed by the quota. Let's see if this is going to go through. So I want to get that 2012 portion with all the quotas 1 to 4. Next, we go to 2013 with all the quotas 1 to 4. Yes, this is the layout we want. And remember, we have a column without a name. This column has no name. The name was provided. Let's just go back to the question and you're going to see the name that was provided. So the final output should have two columns, this and total revenue. Yes, that's the part we are missing. So the final one should have this. I'm just going to put an alias right here and put this in square bracket. So that column now has a name. If I run this, see year and quota, then total revenue. See that the formatting. So with the concat function, there's a lot you can do. All you need to just stick to the requirement. You see how the values here was proposed. This is something we can fetch from the year function. This is something we can fetch from the quota function. The quota does not give you queues. We actually hard coded the queue. The hyphen and the queue was hard coded. So take this expression, concat it to this, concat it to this. Right. So let's end here for today. Right. I will put this together and do some explanations on it so that you can understand what we're doing. And I will encourage everyone to go over these questions. We've addressed some very key strategies that I think you have to know them. Right. Yeah. So let's end it. It's 10 minutes above time. Let's end here for today. Okay. See you on Saturday. Saturday, we're going to continue looking at functions. Right. It is really going to be an interesting session. So week 6 is still functions. If I show you a sample of the objective, it's still going to be seeing functions. Right, these are still functions. This is a very important thing in SQL, and then we're going to get to the window functions. Right, so week 6 is still functions. Right, functions are intimidating. Right, but then I don't want you to give up on this. You have to keep practicing. Right, you will understand it when you put more effort. Right, it's really it sometimes gets frustrating. Too many functions, but of course some are easy to understand. The difficult ones you have to spend more time on them, but the easy ones, practice them once and just understand what's going on. Some functions, from the name you can easily tell what they're doing. Right, so those ones as well, start looking at seeing the name of a function and knowing what it does. Concat is from the concatenation process, which means bringing things together. Right, so you are combining this and this with a space in between. So from these names you can easily derive the use of those functions. Date diff, the difference between two dates, you must have a start date and an end date. Then you quantify the result. Duration in years. You see that we've used the month function. You just extract the month from a given date. Right, the day function extract the day from a given date. You see month, we've seen We use day. Day function goes to a column date, extract just the day. See, so some are really straightforward, you know, but others you will need to practice to understand them. Okay, let's stop here for today. Okay, good night, everyone. See you on Saturday.